Okay guys, here we are, week 11, MyStatsLab problem 5 example from chapter 12. Man, we're really close to the end, aren't we? Well, let's go ahead and look at this problem. An educator randomly assigns students to a program in which some will use new reading activities and others traditional teaching methods. At the end, both groups take a reading comprehension test. Their scores are shown here. And our question is, do these results suggest that the new activities are better? We're going to test an appropriate hypothesis, state our conclusion, and we're going to assume a significance level of our alpha is 0.05. So here's our data in two groups. One group's a little larger than the other. So the first thing we need to do is determine the appropriate null and alternative hypothesis, and I have those here. So like most of our null hypothesis, we're going to say that there is no difference, that the mean of one is basically the mean of the other. So there is no difference between the activities. So that means our alternative hypothesis is going to be that there is a difference and it is greater than 0. So next is and we in the process here of looking for our p-value. The first thing we're going to do is calculate our summary statistics. So for that, the first thing we need to know is the number of observations in each group here, and we can highlight it, and you may not be able to see it on mine, but if you look at the bottom of your spreadsheet, it's going to say count. And we know that's 14. We'll check the other group, make a count there also. The count is 17. Now we also need to know our y bar for each group, which is the mean, and we know in Excel we need to use the formula for average. So we can start typing in average. There it is, double click on it. So we'll highlight our data for set 1, enter. We can do the same thing for the second set, equals AV. There's average again. So we'll highlight that data also, enter. Now we'll also need our standard deviation. So again, Excel will do that for us. So we'll say equals, start typing standard deviation. There it is, STDEV. I'm going to double click, and we'll do the same thing. We'll highlight our data for the first group, enter. Do it one more time, equals ST. There it is. Highlight this group, hit enter, and there we have it. We have all of our summary statistics that we need to get started. Now we have quite a bit more work to do here, and I'm going to switch to another sheet where I have transferred our data and also added a couple more things. So let's look at what I've added. We have our standard deviation here, and now you see that standard deviation squared, which we all know is what? That's right, the variance. So I've calculated the variance for both groups, because we're going to need that when we get down here to our standard error and also our degrees of freedom. And this one, boy, is this a formula here. And since we're talking about formulas, if you look on page 372 in your text, you will see the standard error formula. You'll also see at the bottom of the page the degrees of freedom formula that we're going to use. That may help you to have those to look at. So I've also taken my variance and divided it by n, because that's what we're going to use in both of these calculations for standard error and degrees of freedom. So if you, well, let's click on our standard deviation there, and you see I took our standard deviation and squared it by using the shift 6, and I squared both of those to get our variance. Now I also took that same variance and divided it by n for each group. So I divided that one by C1 that cell. Also here I used E1 because 17 was the number for group 2, and got that number so that we can use that in our calculations down here, and it'll make them a little bit simpler once we get down there. So now we need our standard error. So if you look on page 372, or maybe you already know the formula, we're actually looking for the square root of our variance divided by n for both groups. So now that I already have that number, that's going to make it a little bit easier for us. So we're going to say equals and start typing square root. There it is. So I'll double click that. And we just need to add these two numbers together. So I'll click on that. Plus group 2. Hit enter. And there's our standard error, 3.662. So the next thing we're going to need is the observed difference between sample means. So this is basically just taking one mean and subtracting it from the other. So we'll use our cell again, equals. We'll take the mean of group 1 minus group 2, enter, and there is our observed difference between sample means of 6.635. Now that we have those two pieces of information, we can calculate for t. And in the formula for t, we're going to take this difference between the two sample means that we have here, and then we are to subtract the hypothesized difference. Well, our hypothesized difference is 0. So we basically have nothing to do there. So we take our observed difference here and divide it by our standard error to come up with t. So let's do that. Equals our observed difference there divided by our standard error, enter, and there's our t value, 1.812. Now that we have that, and once we calculate our degrees of freedom, which you see the value here, but I want to show you that number. Also look again on page 372 at the bottom and look at that formula. Boy, isn't it something. So I've actually reduced it some by having the variance and then the variance divided by n already calculated here. But let's click on the cell and take a look at it. And we'll go up here in our formula bar and look at that thing. I've had to square C5 here plus E5. We had to take n minus 1 for each group. So 14 minus 1 is where the 13 came from. 17 minus 1 is the 16. We had to take our value that we have here and square it. Quite a formula. And once we go through all of that, we come up with our degrees of freedom, 26.66. Now that we have our t value and we have our degrees of freedom, we can calculate p-value by using our formula in Excel called tdist. So now we say E equals t, start typing in tdist, there it is. And it asks us for 3 pieces of information. The first thing it asks for is x. Well, that's our t value. So let's click on that, comma. It asks us for our degrees of freedom, which we just calculated. So I'll highlight that, comma. It asks us for the tails. Well, this is an upper tail test. We're looking for greater than. So 1 tail. I'll close my parentheses, enter, and there's our p-value, 0.0408. Now we can conclude, can't we? We have our p-value, and we know that if the p-value is greater than the level of significance, then we are to fail to reject or to accept the null hypothesis. Well, our level of significance is what? 0.05, and our p-value is 0.04. So it is less than the level of significance of 0.05. So there you have it. A lot of work there. This degrees of freedom formula is a bear. I mean, it's doable, but it's a bear. A lot of work went into just coming up with this p-value, didn't it? Well, I have one other way we can do that. And let me tell you, it's a lot easier. So I'm going to go to another sheet. I have copied and pasted my data from both groups here. And this time we're going to let pHstat do it for us. So I go to my add-ins, pHstat. We're going to use two sample tests of unsummarized data and the separate variance t-test. So I'll click on that, and there we go. So everything we need to do is right here, and it's much simpler than what we just went through. It asks us for a hypothesized difference. Well, we know that's 0. So we'll enter 0 here. Our level of significance is already there, and it asks us for the sample 1 cell range. We're going to use the first cell also, the label, because we had that check. So let's highlight the full row of data there. We'll do the same thing for the second sample, including the label. Highlight it there. And all we have to do is check the upper tail test, which we've already said that's what it was, and click OK. And there you have it. Everything that we just took so long to do is there. The means, standard deviations, the whole works. The t-statistic is here, and there's our p-value, exactly what we just calculated on the last sheet, 0.0408, and it tells you the same thing, that we are to reject the null hypothesis because our p-value is less than our level of significance of 0.05. So there you have it. There is your week 11 MyStatsLab problem 5 example from chapter 12. You're almost there, guys. You're really close to being done. Hope this helps you out, and we'll see you maybe one more time. Take care.